Close to the dam site, the converter station takes shape. Here, state-of-the-art equipment will change alternating current generated at the dam into extra high voltage direct current for transmission. A similar station at Kolwezi will change the power back to alternating current for consumption. While the installation of sophisticated equipment proceeds at both terminals, housing preparations are made for the crews which will build the line between them. And as construction equipment and machines arrive, experts turn to the job of training workmen in their operation and maintenance. For some, this is their first opportunity to learn new skills that can help build a nation.
Your size with your calipers, and you see you're about 20,000, about 5 more thousand.
More than 300 heavy trucks, 55 tractors and graders, earth movers, dozens of cranes, and hundreds of support vehicles will be used. Almost daily, the machines arrive from distant points. The stockpile grows. Everything from nuts and bolts to the tools to fasten them. Nothing is left to chance. With the right-of-way cleared, airborne survey teams return to mark the exact location of each of the 8,500 towers. In the isolation of the African plain, concrete is a construction luxury. So a system of special steel footings is used where ground conditions permit. Deeply embedded in the earth, the steel foundations will rigidly support the tall pylons. The rainy season comes twice to Zaire. Straddling the equator, the northern half of the nation is affected before the south. But when it comes, to call it rain is a casual understatement. It saturates the earth. For a time, nature has the upper hand. With the return of good weather, the supply lines now stretching across Zaire reopen. The steel for each tower, weighing a minimum of 7 tons, is readied for transshipment by the complex delivery system of rail, barge, truck, and air. Along the cleared right-of-way, crews begin the erection of the twin towers that will cradle the transmission lines. Each is as high as a 13-story building. Each will need more than 400 pieces of steel, joined by nearly 1,400 hand-placed bolts. The world's longest power intertie ever built as a single project takes shape under the hot African sun. Representatives of Snell and its advisors, the U.S. Bureau of Reclamation, check progress. With good weather, one tower can be built in a day by each crew, a tribute to hard work and sound planning. The dual towers, spaced an average of 400 meters from the next set, will each carry a bundle of 3 conductors from Inga to Shaba. Even jungle swampland gives in to the steel giants. Whirring rotors carry in an inspection team, interrupting the natural wilderness sounds. As a construction and engineering firm that has performed major projects in more than 70 countries, Morrison-Knudsen is no stranger to the remote areas of the world. But Zaire posed new obstacles, and there's obvious pride in the men on 2 continents who overcame them. Near the city of Kolwezi, vast open-pit mines dominate the landscape. For many years, this government-owned mineral development has played a decisive role in Zaire's economy. Today, minerals account for more than half of the country's export earnings and 1/4 of its gross domestic product. Here in this sprawling smelter and metallurgical complex, power consumption rises with production. In Shaba, land of cobalt, zinc, and copper, industrial growth will be sparked anew by energy from the intertie. On a plateau above the rapids, the Inga converter station is the source of the direct current, feeding the transmission line reaching 1,700 kilometers across savanna and jungle to its southeastern terminus at Kolwezi. Here at Kolwezi, another station will convert the direct current to alternating current. Both converter stations will be expanded as power needs increase. Within the cavernous Kolwezi valve halls, electrical equipment will change direct current into 220 kilovolt 3-phase alternating current for distribution in the Shaba region, with 110 kilovolt service available through step-down transformers. Electrical equipment in each valve hall includes 280 megawatts of converter groups with banks of single-phase transformers located immediately outside the walls. Their terminals project into the building. The transfer of technology continues. Career training in high technology areas is a keynote of MK's commitment to the people of Zaire, who will operate and maintain the system. Situated at strategic points along the line are 4 switching stations. They assure minimal interruption of service by interconnecting and shunting power from one line to the other for maintenance and repair purposes. The system is designed so that energy can be tapped at each station when industrial demand develops nearby. The stations also serve as relay and message centers for a communications network which is part of the system. Now, work begins on the final phase of the transmission link itself. Like necklaces, dozens of insulators are strung, and workmen climb once again, now to affix the insulators to each steel arm and to ready the towers for the conductor cable.